Yeah. Good morning everyone. This is Jagadish Kumar. Today we are discussing about GDPE, garment dyeing, printing, embroidery. So we are in unit 3 and this is video 3 about. So if you consider the GDPE unit 3, it is mainly concentrated about garment finishes. So in unit 1 we have seen garment dyeing, in unit 2 we have seen garment printing techniques, and in unit 3 we are seeing the garment finishes. So earlier we have discussed about the various finishes and their classification for fabrics and also garments, and also we discussed about the fragrance finishes, UV protection finishes, cool and thermal finishes, and water permeable or water resistant breathable finishes, vapor permeable finishes. So we will be discussing some of the functional finishes in this video, like wrinkle free or ETA finishes. So many of them are like resin finishes. So it can be either ETA, WR, durable press, DP finish, all are nothing but the same. Okay. And also we will see a brief about antimicrobial finish in view of this Harvard 19 and all, even though which is not specifically mentioned in terms of the syllabus. Then we also will see some of the soil release or stain release finishes, especially like the feather touch finish or rubber touch finish or the Teflon coated finishes, basically, which will improve the wearer easy care. Okay, so this we are going to discuss in this video. Okay, basically we will start with the resin finishes like WR, okay, wrinkle resistant finishes, durable press finishes, or ETA, easy to iron finishes. All of them are nothing but the same. Okay, we will concentrate mostly on this. This is basically achieved through a resin treatment, and all. It's most commonly used. And antimicrobial, what is this and how it will be used? Like all the masks and healthcare things and all, which generally comes with, that is also one of the functional finishes, or antimicrobial finish. We will see that one. And also we will see some of the softener washes like feather touch, rubber touch, or the softener washes, and a Teflon coating. Okay. So ETA, wrinkle free finishing process. What is free? Whether wrinkles are free? It is free from wrinkles. Wrinkle free means it is not that it is free, so many wrinkles will be there. Wrinkle free is as a meaning that it is free from wrinkles. Okay. So the finishes which are specific like WR, wrinkle resistant, wrinkle free, or durable press, DP, and permanent press, or ETA. All of these names are same and we can use them interchangeably. Okay, we can use them interchangeably. All of them are nothing but the same. So these terms all apply to various types of finishing agents. Okay, based on what kind of agents and which process and all which can be used, but the objective is same. Okay, to make it non-wrinkles. So to make sure that there are no wrinkles. That is the primary objective of these wrinkle-free finishing processes, commonly referred as ETA finish. What is this ETA, sir? ETA means easy to iron. Easy to iron. Okay, that means ironing or pressing will be there, right? So, cotton is a basic cellulosic and which is generally hygroscopic in nature. When it reacts with the water, okay, so obviously what will happen? It will tends to create a semi-permanent bonds, such that what will happen? The finish or the basic mechanism or this van der Waals forces will be acting when the water is mixed with it is going to change. So in its nature itself it is there that the wrinkles or creases will be formed. The wrinkles or creases will be formed, especially to the cellulosic fibers. So whether this ETA and all is required even for polyester and all, if it is 100%, the polyester fabric may not be required. But if it is a cotton polyester blend, okay, in those cases these ETA finishes are required. Okay. Will it be very expensive? Now per meter maybe 5 rupees per meter. It is not very expensive. Okay. So this is one of the most commonly used functional finishes. Okay. It can be referred as either wrinkle resistant, wrinkle free or durable press. So there will be a slight difference. Durable press means what will happen? So before that, before explaining durable press, now two words. One is wrinkle, one is crease. What is the difference? Whether both the same? Wrinkles and creases. Both are generally formed. Okay. Now crease is a deliberate fold of the fabric. Creases are pleats, which are deliberate creation as per the design requirement. Creases. Okay. But wrinkles are unwanted creases or wrinkles. Okay. There is no following of in a specific order or something for the fold. That is referred as wrinkles. It's a chaos. But a crease is nothing but a deliberate fold in the fabric. Crease is nothing but a deliberate fold in the fabric. So once we give this ETA finish and all, how we will come to know, how we will measure it? Basically with the help of either crease recovery angle, CRA. Crease recovery angle. Generally for cotton and all, the recovery angle is very less. But whereas in polyester and all, it is better. So what happens? ETA is a finish which will improve the crease recovery angle. Okay. Okay. So this specific finish, durable press finish. So in this what happens if we want a crease at some space, maybe at a blazer the crease which is there, or at a formal trouser the front pleat, where near the pleat wherever it is there the crease. Okay. If those creases wanted to be permanent, okay. So those are nothing but the durable press. Means whatever, as like if you are pressing, how wherever the creases will be there, these creases will be fixed. Okay. We will see how the kind of resin is being impregnated. There are 4 types of methods and all. We are going to discuss it. Okay. So what I wanted to understand from this slide is the wrinkle resistant or wrinkle free, durable press or permanent press or ETA finish, okay, or easy care finish, okay, in terms of ironing. All these are nothing but the synonyms and which can be interchangeably used. Okay. So resins are the ones which are most commonly used in order to get rid of these creases or wrinkles. Okay. So the resins are nothing but the cross-linking agents which react with the OH groups. So how many, the cellulose, the monomer is referred as cellulose, right? How many free OH bonds will be there? 3 free OH bonds. 3 free OH bonds will be there. Okay. Out of this, either 1 or 2 will be forming with this resin. Okay. That's not 100%, some of them, so that it will restrict its movement. Okay. So you can see in this figure what is happening. A cellulose polymer and also another cellulose polymer, and in between the molecule which is there is nothing but this molecule is nothing but the resin molecule, which forms a bond between 2 different cellulose polymers. Okay. So these resins are nothing but cross-linking agents. Cross-linking agents which react with the OH groups. Okay. And again, these OH groups are responsible for creation of the creases or wrinkles. Okay. So by chemically stabilizing these OH groups with a cross-linking polymer or agent, what happens? It will not react with the OH. Okay. These 3 OH groups are bonds are responsible for even attraction of water also. So what happens? It is like we are making it inert. Making it inert. The OH groups are becoming inert. So once it is inert, obviously what will happen? Of course, whatever the problem with respect to the creases or wrinkles, that can be resolved. But again, whatever the absorption, the water absorption which is there, that also may get affected. And as it is being cross-linking, sometimes what happens, the strength also will be reduced. Okay. Yeah. So basically, the resins are the cross-linking agents which react with the OH groups of cellulose materials in acidic medium at a pH of 3 to 4 to form the covalent bond. Covalent bond means oxygen, O. Okay, double bond. So with the covalent bond means it is a stronger bond. So that means it will remain for good number of washes. Okay, it is not permanent bond, but obviously covalent bond means chemically it is a stronger bond, isn't it? So you can see this picture very clearly now. Okay, how this resin is interacting with two sets of cellulosic polymer chains. So these resins are commonly used to make cellulosic fabric, that is cotton is one thing, and sometimes what you call even this viscose rayon also, and their blends make these fabrics into a wrinkle resistant fabrics. Again, wrinkles are, there is no pattern, okay, chaotic way of folds, and creases are nothing but a deliberate crease, deliberate wrinkle. Crease is a deliberate wrinkle. Okay. Wrinkle is a unwanted creases. Isn't it? Crease or wrinkles are nothing but the folds. Okay. The folds which are wanted is a crease, and which follow a specific pattern, that is a crease. Which does not follow, obviously it's a wrinkles. So cotton fabrics are prone for wrinkles. Okay. Not cotton, all the cellulosic, okay, which is having OH. Okay, even linen also is having wrinkles. Is it? All the cellulosic fibers are prone for wrinkles. So these wrinkles must be avoided by means of cross-linking by this sort of resin treatment. So what are the types of resins? Okay. So the deposition type of resin, these are like, it will not react actually with the much of this thing. So these resins, the deposition means it will deposit on the surface. These resins are deposited on the fabric as a surface coating, as like a knife roller or some of the coating technique can be used. Okay, so what happens, it will be deposited on the surface, and no reaction will take place between the fiber and resin. This is one type of resin. Okay, these are like phenol formaldehyde resins, urea formaldehyde resins, alkyd resins, ketone resins, vinyl resins, as like vinyl print we have discussed in the earlier GDPE, right? Similarly, those means it will not react, it will form a base and it will not react to the fiber level, but on the texture and all it will forms, and it will be having some sort of a good strong hold onto the substrate. Okay, these are what? Deposition type of resins. Okay, so here if you want to make it wrinkle free, more amount will be coated such that air permeability will be lost, and that. So for apparel purposes, these are not much recommended. These are not much recommended, but for technical applications and these can be used. For technical applications and these can be used, but not for the apparel applications, the deposition type of resins. Okay, these are least used. And the other one is the cross-linking type of resins. So as like in the figure we have seen, right? So it will cross-link between various polymer chains. It will be referred as a cross-linking type of resins. So these type of resins chemically react with the fiber and cross-link the fiber molecules. Okay. So most commonly used is DMDHE. Okay. So this type of finish obtained is durable. Okay. Why? Because the peel-off will not take place, and these are reacting with the polymer chain. So obviously, what will happen? It will make a good bond, and these are much better than the deposition type. These are much better than the deposition type. So one is DMU, methyl urea. So DMEU, dimethanol ethylene urea. DMDHEU, dimethylene dihydroxyethylene urea. DMDHEU is the commonly used resin for cross-linking of cellulose polymers and make it into various, means again we haven't discussed that part, right? It also makes the surface into water impermeable also. Okay, as it does not react with the water, obviously the hygroscopic nature will be down. Okay, isn't it? So the water repellency will be increased. Okay, so the resin finish will also improve the water repellency also. Okay, apart from the making it the wrinkle resistance and all. Okay, it can be used for both purposes. So our primary objective is anti-crease. Okay, so for cellulosic fibers. In case of polyester or any other things also, this DMDHEU, in case we used either to make it wrinkle resistant and also make it less absorbance to water. So this anti-crease finish, the purpose is to prevent the deformation. Whatever the fabric structure is there, it should not get deformed. Okay, the fabric by undesirable and unintentionally introduced folds. As we discussed, the creases are the ones which are sometimes permanent crease finish. Okay, permanent crease finish. Like for my blazer, if you see in the sleeve, there is a crease, okay, which is intentionally required maybe for folding. Similarly, some of the formal trousers also, those are intentionally required. Intentionally required creases, permanent crease finishes, or durable press finish, or nothing there. However you are pressing, the same thing should be maintained. That is referred as a durable press finish. Okay. So unintentionally introduced folds should not be there, but intentional folds must be there. We are not saying that there should not be any folds. Then it will be very difficult to fold it and pack it, and even the transportation, and it does not give a good feel, right? But we want only intentional folds. Okay, anti-crease finish. Understood? Similarly, if you see anti-crease finish, wash and wear finish. Means you wash it, you wear it. No need of ironing. Isn't it? So when wash and wear finish is applied onto the cotton, it does not wrinkle too much. Okay, and becomes easy to maintain. Easy to maintain. After washing, you can wear it directly. If dried and handled properly, wash and wear fabrics can be worn without ironing or with a very little ironing. This wash and wear is also commonly referred as ETA. Also commonly referred as ETA finish. Okay. So again, these are the synonyms depending upon how much amount of resin we are giving and all these things. Some brands will maintain something. Okay. But all are nothing but the core concept of these wrinkle resistant finishes are nothing but the same. Okay, which reacts with the free OH bonds of the cellulose and which restrict to make the bonds in between, so that whatever in its nature it will remain flat. Okay, that is common. Then, so another one is durable press finish, anti-crease finish, wash and wear finish, and durable press finish. So in the dry state, what happens? The cellulose chains are held together by the hydrogen bonds, OH, so which break on coming in contact with the moisture. So again, this moisture, when it goes on, what happens? Temporary bonds will be there wherever when the moisture is leaving, right? In that state only it will be there. Again, when moisture comes, it will form another temporary bond. That is the basic nature in the cellulose. So in this case, what happens? The formaldehyde resins. Okay, these cross links are quite stable to laundering since the covalent bond which is being given, right? So even the laundering and also it will withstand, and it will allow the fabric to put through the machine washing without wrinkling or losing the desirable pleats or creases whatever we wanted. So while cross-linking and all, if we kept the garment in the pressed condition and cure it, okay, so that crease will remain. Okay, understood? So that is nothing but the DP, durable press finish. So the process sequence is like in case of fabric. Okay, so padding, drying is done. That is the fabric. Okay. So this fabric is cut and made into garments. This fabric is cut and made into garments, and insert the creases or pleats by means of hot pressing. Then it will go for the curing. So in this curing, what happens? It will be there as like it. Whatever the folds are there, it will remain as it is. We cannot remove it. So after curing, washing, any excess amount or any debris which are found will be gone. Then the wash is required, hot rinse, cold rinse, and then drying of this garments will take place. So in durable press finishing, so what happens? One is the finish is applied to the fabric through padding, and then it is dried, which is sent to the garment industries. The fabric is cut and made into the garments and insert the creases wherever it is required. Then it will go for curing. So what happens? It will be set after the curing. This is one way. Our other way is you make the garments, you treat with the resin, as like yesterday we were discussing, right, in a couple of classes before about the various ways to finish the garments, either through dipping or through tumbling method. Dip method or tumbling method. Tumbling method means where there is spray. So the garments treat with the resin, then hydro extract, press and form the creases. Okay, at normal temperature, and pleats with the hot iron wherever it is required. Then the dry curing at 150 degrees, depending upon the what kind of resin and how much concentration, and again even the type of manufacturer for that resin also will affect the temperature. Either 120, 130, 150, 170 also will be there. Then again hot rinse, cold rinse, and then dry. This is the most commonly used method. We will discuss in detail again the durable press finish. Okay, so the earlier two are like easy care and all are basically given for the fabric sector. This coating is given to the fabrics, and then the curing will be done after the garment making. Or you make the garments, then itself you apply this resin or the chemicals, and then you make pressing and all. Yes, it is a laborious task only. The process sequence is longer. Yes, I agree. But in order to make the garments wrinkle free, okay, so this is the most commonly used method, the DP, durable press finish. So the common recipe which can be used for this durable press will be DMDHEU, dimethylene dihydroxyethylene butadiene, 200 grams per liter, that means 20%. Okay, and magnesium chloride, 6H2O, 20 grams per liter. Then polyethylene emulsion, 25 grams per liter. Then acrylic emulsion, 30 grams per liter. Non-ionic wetting agent, 3 grams per liter. Wetting agent. So these are the chemical recipe which is commonly used for this durable press finishes. Okay, it can be applied at the garment stage, but before the final curing. Yeah. So most of the blazers also generally comes with this kind of finishes. So the advantages of the resin finishing, if you consider, it improves the crease resistance and crease recover property, the CRA, crease recovery angle. It will definitely improve. Okay. It reduces the shrinkage during the laundry. Why? Because it is becoming the cross-linking agent and all. Whatever the shrinkage which will be there during the laundry, it cannot be a problem. Means the shrinkage is handled. It gives a smooth and quick drying property. Okay. It is not talking about feel. Okay. only the drying property is faster. The amount of time it requires for drying will be lesser. It improves the resilience, that means the stiffness will be improved, handle, and draping quality also improved. Instead of the fabrics being limp, it will become somewhat stiffer, and like if you apply starch or something. And also it improves the weight and dimensional stability. It improves the weight and also the dimensional stability. Okay. So this resin finishing also gives the resistance to degradation by means of light and laundry. The light fastness will be lightly improved. Okay, but excess chemical of this DMDHEU can cause discoloration of the thing which is already there. But whatever the light fastness, property can be improved. And it improves the fastness to light and also washing to many dyestuffs. Okay, it improves the light fastness and also washing fastness by means of giving this resin light. Okay. So when we say advantages are there, so obviously some of the few disadvantages also will be there. So one is the environmental effect by means of release of free formaldehyde. That is one problem. Okay, which is not good, and sometimes this is carcinogenic, and in excessive amount may leads to various genetic problems to the human beings. And this is one of the environmental concerns. And it reduces the tensile strength of the fabric and tear strength of the fabric. We can say up to 20% strength loss may take place. Up to 20% of strength loss may take place. And also it decreases the abrasion resistance. It decreases the abrasion resistance. It forms a layer, yes, of course. So initially it will propose a very strong this one, but once it comes peel off under, it will easily come out. Okay. And the next one is odor. It gives bad smell. And the feel and all, if you consider, it gives harsh feel and stiffer feel. Obviously we understood it. It becomes more stiffer and weighted. Okay, stiffness and hardness also will be improved by means of this resin finishes. Okay. Apart from this, the other things are like color strength and strength loss, color change and strength loss. Okay. So this is about the basic finishes. You see the process, how this ETI or this durable press. So basically there are 4 techniques. We have already discussed one, that is the dip spin. We will see. So basically there are 4 methods or 4 different technologies which are known for this wrinkle resistance or crease recovery. Okay. Those are referred as pre-curing, post-curing, dip spin, vapor phase. Pre-curing means the fabric itself is applied with the resin and then the curing is also done. That is referred as pre-curing. Post-curing means the fabric will be done and it is cut and made into, then it is nothing but post-curing, most commonly used. Okay, sometimes. And the more advantageous is dip spin. As like once you make the garment, then you apply the chemical, then you cure it. That is nothing but dip spin. Okay. The dip method of what the garment finishing. So in first 2 are nothing but the fabric finishes. The next 2 are like garment stage finishing. Dip spin means the garment is made with the normal fabric itself, then the chemical will be applied, and then what happens, it will be went for curing. Okay. The 4th one is vapor phase. That means the liquid will not be done, but the chemicals itself will be directly injected into the garments, where the garments will be hanged and these chemicals in terms of the vapor form will be applied. Okay. It is little dangerous and all, only few countries will be followed. Dangerous not for the wearer. During the manufacturing and all, these vapors and all, if it gets leaked and all, it is a problem. If it is in the liquid state, okay, no issue. But it's in the vapor form, or the persons who inhale and all, they will feel many of the problems. Okay. So that is the reason the vapor phase is not made. We will see in brief about these ones. So basically we can come to 4. Pre-curing, the fabric itself is cured. Okay, the cured fabric we will use. Post-curing means the fabric is treated but curing is not done. It is done after the garment making. Okay. Then dip spin. Dip spin is nothing but the garments itself are dipped into the liquid state, the liquid or this resin chemicals and then it will be done. Vapor phase means not in the liquid form but again in the garments. So pre-curing means the fabric itself is completely finished. Post-curing means the fabric finish is applied but curing is done at the garment stage. Dip spin means the chemical application and also curing is at the garment stage. Vapor phase means it is also same like dip spin, but only thing is that it is not in the liquid but it is in the vapor form. Yeah, I hope you have got some idea. Yeah. So in all 4 systems, the cotton fiber is swelled artificially and by this process losing its memory. Instead of being curled as it naturally is, it becomes straight. And as increased its diameter, it almost impossible to crease and loosen a part of tensile strength also, and it has lose its habit of absorption moisture. So in case of pre-cured fabrics, fabric can be 100% cotton fabric or cotton blend. So contradicting to all other wrinkle resistant process, this process, fabric itself, it does not require any of the further heat treatment. Okay, so the fabric itself is treated, understood? So it does not need any further heat treatments for curing process. Why? Because the curing is already done. Okay, so before the shirt manufacturing itself, the curing is done, understood? Yeah. So what happens if you want any of the creases or something at specific points, like maybe collars or cuffs and front line pleats, and it is impossible to hit it. That is one of the problems. Why? Because the fabric is treated. Okay. As already finished fabric is resistant to wrinkles already, so you cannot create any pleats. So unfortunately, the crisp and sharp creases can be a problem for collars, cuffs or front placket edges. Okay. And as the fabric does not accept any final pressing, only a shirt finisher with steam and air is required. Only with steam and air. No, there will not be any pleats and all for the sleeves will not be created. For the front also, this will not be created. Why? Because it is a pre-cured fabric. It is a pre-cured fabric. Understood? So creases formation is difficult. So in case of post-cured, this problem will not be there for the garment. In this case, what happens? The fabric can be of either 100% cotton or cotton blends also. The fabric will be delivered with the curing chemical inside. Okay, whatever the resin which is there, which is already impregnated and applied but not cured. So these rolls of fabric are sealed in a polyester bags. Why? Because along with the oxidation and all may loosen its affinity. Okay, and also the shelf life of fabric also is is an important parameter to consider. Okay, you make the fabric now and after 3 years, if you want to make the garment, it is not good. The shelf life should be within 3 to 6 months, not more than that. Understood? The purest fabric. So these fabric rolls are sealed in the poly bags. Okay, the plastic bags. Okay, so that the oxidation cannot be done. So once the bag is opened, the fabric has to be manufactured entirely. It is not good for storing for a very long time. Okay, 3 months is the general time. So once the shirt is manufactured, means we cut it into, and then whatever the seams which are there, everything is done. It has to be pressed entirely. Entirely it will be pressed at a high temperature, wherever our creases are required. And once it is done, it will be kept on a hanger and it will be cured in the hanging position on a cloth rack inside an oven. Okay, as like in spinning and all, you might have observed the yarns which will be gone for conditioning. Okay, similarly, at 130 degrees centigrade at 3 to 5 minutes. Again, it's depend upon type of resin under it, may be 120, 130, 140, 150, 170 also. Okay. So this finishing should be given in such way. So once it is done, now the shirt is ready for folding and bagging. It means it can be sent out further. Okay. This is for the post-cured fabric. Okay. Means the fabric is impregnated with the this resin finish at the starting, but it is not cured properly. Okay. It is not completely cured. It is made into the garment and then cured. This is nothing but post-cured. The dip spin method is this dip spin method. So this one belongs to the most popular process for wrinkle-free shirts or the garments, and can be used for again 100% cotton or cotton blends. So after the shirt is manufactured, as usually, it will be dipped into a mixture of chemicals which will be absorbed by the cotton fibers. Understood? So the shirts are manufactured, then the chemical application is going to take place. The dip spin method. So once the treatment is done for 5 minutes or 10 minutes, then it will be transferred to a tumbler. Okay, tumbling machine. So where the shirt is still moisturized and has to be pressed there. Some amount of moisture will remain. So then the ironing will take place. So the important thing is that during the pressing operation, so the specialized things like collars, cuffs, or body presses, or the shoulders, wherever it is required, it needs to be properly done. Okay. Then it will be sent for curing. So after pressing, the shirt will be put on a hanger and can be cured for a curing chamber. Again, around 120 to 170, normally 130 to 150 degrees centigrade for 3 to 5 minutes. Okay. So here, one thing you need to consider is that the key factor for a perfect appearance is the pressing quality. What happens during the curing, however you have kept in the curing chamber, the same will be fixed. Okay. So as after the curing operation in an oven, all wrinkles will stay for life. The retouching of iron is impossible. So whatever you are forming this wrinkles and all, it will be fixed. If any wrinkles are there, it will be remained. There is no repetition action. Okay, it is like a one time. Once it is cured, thermoset. Okay, once it is cured, you cannot go back to the temperature and again do it. It is not possible. So that is one of the problems, the dip spin method. Okay, and of course, which is the quite commonly used. And the fourth one is the vapor phase, which is not generally used. This curing system can be used in some countries. Only very aggressive chemicals are okay to use in the industries. So it's similar to the dip spin method, but the shirt is manufactured as usually. So after that, the final pressing, a special curing oven is used instead of the liquid chemicals. Gas is used to make the shirt resistant to wrinkles. The gas is circulating through the oven and penetrates into the cotton fiber. So at the higher temperature itself, the gas is also injected. So the chemical dosing will be less. So environmentally means most of the effluent will not be wasted. Means chemical wastage can be reduced. But people who are operating near to these machinery are at a greater risk. So that is the reason generally these are not much recommended. Either the dip spin method or post curing of the fabric is the common methods which will be used, and these are generally referred as a durable press finishes. Okay, I hope you know some of these things, and it's worth discussing again. So I hope these finishes are the garment finishes. Okay, are very useful. So in terms of this vapor phase, once the gas has to be evacuated from the oven and all, which is removed, and the shirt is folded and then bagged. It needs to be washed, hot wash and cold wash. Any leftover chemicals which are there, it should be removed before sending to the final shop center. Okay, so here we are going to see a video about this resin finish applications, pre-cure, post-cure, and the dip method also.
In this segment, we describe how different chemistries can be used to improve the serviceability of fabrics. The first class we address is fluorochemicals, which are particularly useful for providing water and soil resistance. Water repellency works because the chemistry increases the surface tension, causing water to bead. Fluorochemicals are the most water repellent of all finishes, but are also the most expensive. The same repellency also prevents soils or stains from entering the fabric and forming a bond. And this type finish is durable to laundering. Clothes that are easily soiled must be finished to both repel and release dirt and grime. Fluorochemicals can be adjusted to provide less surface tension, so that the finish releases dirt and removes soil during washing. Contemporary lifestyle dictates that we look neat while we work hard and play hard. So fabrics can be treated to resist wrinkling, to retain a smooth appearance, keep creases and pleats in place, even after laundering. Currently, the most popular chemistry used to resist wrinkling is resin-based. Many factors related to chemical reactions influence wrinkle-resistant properties. The reactant concentration, the catalyst type, and the catalyst-resin ratio are of utmost importance. There are three main methods of resin finishing applications: pre-cure, fabric post-cure, and garment post-cure. The pre-cure process occurs after fabric has been dyed. First, the resin, a catalyst, and softener is patted onto the fabric. Then the fabric is dried and cured at an elevated temperature. After this, the fabric is cut and sewn. The process is quick, inexpensive, and reproducible. Following pre-cure, the garment is assembled and sent to the customer. Almost all shirts and many slacks are made from pre-cured fabric. Because the fabric now has a memory for the flat, smooth state in which it was cured, creases in slacks will not be as durable as those produced by the next process described. In the post-cure process, the order of events is different. It begins the same way, by patting on the resin and drying the fabric at a low temperature. Next, the garment is cut and sewn. The desired creases or pleats are firmly pressed into the garment. As the final step, the treated garment passes through an oven to cure at higher temperatures, so creases are more permanent. Instead of applying finishes to fabrics, resins can be applied to a completed garment. One method is garment dip. Garments that are first cut and sewn are immersed in a chemical bath. After this, the garment is tumble-dried at a low temperature, which also pre-shrinks the fabric. Next, the garment is pressed. Finally, the garment goes to an oven for curing, which is when the resin chemically reacts. A benefit of this process is better inventory control, because garments are finished only when orders arrive. The garments produced by applying resins and garment dipping shrink less and have better fit. There is a softer hand than that produced by the conventional post-cure method. A second method associated with garment resin applications is metered addition. With this approach, cut and sewn garments are sprayed while tumbling in a garment machine. There is much less waste in chemicals because a metered or measured amount of water and chemistry, just what is needed, is sprayed on the garment. You've seen many different ways that fabrics or garments can be treated with chemicals to improve wash and wear and wrinkle resistance. There is yet another way to soften and improve the appearance of fabric that is becoming more important. Found in all living organisms, enzymes are specialized proteins that serve to attack natural catalysts for biochemical reactions. Safe and easy to use, enzymes attack and degrade specific substrates under mild conditions. Enzymes replace harsh solvents and other organic compounds used to finish fabrics. Enzymes are specifically engineered to create certain attributes. Improved effects include softness and better color washdown. The stonewashed look applied to denim is usually produced by combining an enzyme treatment with the action of pumice stones. Also, enzymes impact the removal of surface fiber or fuzz that appears and makes fabric look worn after many washings. Fabrics treated with enzymes and subjected to mechanical agitation are less likely to display these undesirable surface characteristics.
you understood the different types of wrinkle resistant finishes, their advantages, applications, methods of applications, and their disadvantages. Okay. So now let us stick to the next finish in this video, which is a antimicrobial finishes. Okay. So in the recent time, due to this COVID pandemic and all, it has been coming to more existence and all. So I just wanted to give you some insight, even though which is not there as per the syllabus requirement and all, the antimicrobial finishes. So generally these are given either to the fibers and the fabrics itself, not specific to the garments and all. But again, it can be given as like the dip method and all, the dip and spin method, or through spray technique also, like the tumbling method also can be given. So as like in this figure, you can see the microbes like bacteria, how it will be. Okay. So the necessity of antimicrobial finishes is to maintain and control the microorganism growth, to protect from the viral infections as like COVID-19 and many other viruses, which is caused by the pathogenic bacteria, to optimize the rate of metabolism in microbes, to reduce the generation of odor, like inner garments, socks and all, antimicrobial finishes must. Okay. And to save the quality of the textile materials from unexpected staining or fade out of color and quality deterioration. Okay. Just I wanted to give you one example. So when I was working in one of the garment industry as an associate, so what happened, the biggest problem is like, the biggest complaint to the factory is odor of the garments. So whatever the garments which are manufactured, so what happens, it will be gone in a sea shipment. So once the garment which is packed and kept in a bag and then kept in a carton bags, kept in a sea container, and then which is gone to the other country after 3 months, maybe 60 to 90 days, when it will open and it will gone to the warehouse and all. When they open, what happens, they say that it smells like Indians. Okay. So it's a bad thing for our country, but of course, basically what happens is the microbe growth is higher. So what problem is there like that if it is understood? So basically the kind of water and some sewage water is also not completely cured, which will be used for the steaming, which will be used for steam making. Okay. So in that some of the microbe activity is still there. So what happens once it is closed and all, it is cellulosic, so this microorganism will be keep on growing and it produces lot of bad smell. Understood? The garments when it is opened after 2 months to 3 months. So sometimes what happens is specific as like naphthalene balls or some of the odor controlling mechanisms are also need to be packed along with the garments once it is done. Understood? Okay. So yeah, last point, to save the quality of the textile materials from unexpected staining. So how microorganisms will create stains? Yes, bacteria will eat in places and where it will form some of the clusters. So that is also a biggest problem. And so by means of giving this antimicrobial finish, what happens? It can be saved. Okay. So now all the masks and wherever it is used for the healthcare purposes. Okay, maybe like healthcare gowns, masks, caps. Okay, all these things should be given with a ETI. Sorry, it should be given with a antimicrobial finish, definitely. Yeah. So basically, what happens is, in this case, the principle of antimicrobial or antibacterial finishes. Say the substrate which is the extreme which is there, okay, so which have this fibers or something, so where this red color one is nothing but the bacteria or bactericidal agents. Okay, so what happens, the live bacteria will be there and then the dead bacteria. So when the live bacteria comes, so what happens, this bactericidal agents will be released in such a way that it will be dead. Okay, that is one way. Or other way is this live bacteria comes and sits on top of this, so that it will be dead. It will be dead. Okay, and these agents will remain there itself, so that it will make into more durable finish. Okay, so basically when the bacteria comes in contact with the fabric surface, it should be dead. That is the basic principle. Okay, in this two types are there. One is leaching type, another one is non-leaching. So the conventional one or the normal one is the leaching type. So which is antibacterial, diffuses from the garment, forming a sphere of activity. Any microbe coming in contact with sphere and destroyed. So what happens is the durability will not be there. Okay, the sphere will consist of these chemicals as like micro-encapsulated, and when this microbe or this the bacteria comes in contact, it will hold open and then it will kill the bacteria. This is one type, leaching type. So these leaching type antimicrobials have the textile and leave the textile and chemically enter or react with the microorganisms acting as poison, which will kill it. So this type shows pure durability. Why? Because the sphere is getting broken, the capsule is getting broken. So obviously what happens, the durability will not be there. Okay. And sometimes this excess chemical and all may cause health problems to our skin also. It does not react only with the bacteria. It may react with the skin also. Okay, this is the leaching type. The non-leaching type, antimicrobial. So these antimicrobials being bound to the garment and do not mitigate off. It will not go away from the garment. It will remain. And like in the earlier figure A and B which we have seen, right? It will not go away from the garment. It will release, it will stay with the garment itself. But destroy the bacteria coming in contact with the surface of the garment. Okay. So it will not disperse anything. It will not go away from the garment. It will remain with the fabric. So what happens? Any bacteria which comes in contact with it, it will kill it. So the chemical gets attached to the substrate. That means the fabric. The chemical attached to the fabric either by chemical bonding or polymerizing, as like a thin film or chemical bonding. So some sort of binder also is required to hold these chemicals, and by means of polymerizing, forming a layer on the surface of the treated fabric. Understood? So in chemical bonding, as like high Q masks with the silver technology and so they are incorporated this chemical within the fiber and yarn structures. So that is the chemical bonding. Sometimes a coating or polymerizing on top of the fabric. Okay, that forms a layer. In non-leaching type, this is normally used. So the microbes which do not consume the chemical, instead the chemical acts on the cell membranes of the microbes. Okay, which will not consume, it will not eat. So, but it will act as like a sharp knife or something, so that the microbe will itself will die. So, what it will make? It will make the finish into a permanent finish and will remain effective for very substantial length of time, even up to more than 40 laundry washes. So, laundry washes means we can call it as a permanent finish. We can call it as a permanent finish. It's non-leaching type sometimes. So, if you see this figure, A is repelling surface. Whatever the live bacteria is there, what it will do, it will repel it. It will not allow to enter. That is one thing. The leaching type means what it will do, it will release the chemical and it will make the bacteria into a dead one. Okay. The third one is the contact kill surface. Non-leaching type is basically whatever the bacteria which comes into that zone, it will be dead. Okay. It will be dead. Yes, it is proven. Yes, it is proven. So this is the non-leaching type of antimicrobial finishes. Okay. So I hope you understood the fundamentals of antimicrobial finishes. The next one is the soil release finish. Soil release finish. Soil means dust, dirt. The dust, dirt and all should be removed. Okay. So basically what happens, the surface tension or adhesion. Okay. Sometimes electrostatically sometimes electrostatically charge also will attract the dust. That's why we have discussed it, right? Anti-static charge. So that also comes under the part of soil release finish. Okay. Understood? Soil release finish means it should not react with it. It should not react with it. That is nothing but the soil release finish. It can be done either through the mechanical adhesion, okay, or adhesion by the electrical forces. Adhesion by the electrical forces. Mechanical adhesion means we will coat something on top of it. Mechanical adhesion. Adhesion by means of electrical forces. So the electricity which is available in such a way that which will repel the plant. Or by redeposition of soil during the washing. That also will create our damages. So surface tension dynamics on water repellent finishes. Okay. So normally water repellent finish is there, it will repel. But if the fabric is having the soil or dirt, so what it will happen? It reacts with water in a different way, such that what will happen? The finish of water repellency will get tampered with the soiling action. So soiling itself is a problem. It also damages the water repellent surface. Okay. So that the surface tension is going to change. Understood? I hope you are understanding the mechanism of the soil release finish. Now if you see in this figure, what happens with the fiber and the fluorocarbon blocks. Okay, fluorocarbons are the ones which are generally used. Okay, so if it is not there, the fiber, what it happens? The fiber will be causing, due to this fluorocarbons, the static electricity. With the air, it will react slightly. Okay, that means the vapor phase is okay, no problem. It is not completely blocking the surface. Okay, the vapor phase with the air, what happens? It can come and go, no problem. But with the water, what will happen? It will show the hydrophilic block. Okay, with the air, it acts normally, but with the water, what will happen? A lot of resistance will come into the picture. Okay, so fluorocarbons, tetrafluorocarbons or Teflon is the one which is commonly used. Okay, I hope you understood this mechanism. Okay, the mechanism of soil release through the fluorocarbons. Okay, so as the Teflon, what is Teflon? This is a new generation multi-purpose lubricant based on the polytetrafluoroethylene. Polytetrafluoroethylene, continuous long chain. So in service, this lubricant forms a tenacious non-stick coating of the fluoropolymer, which does not allow dirt or dust to settle on the textile surface. So that is the reason the Teflon coatings are very much normally used nowadays. Okay. Afterwards, even the nano surfaces. Okay. Nano also means this Teflon is also a part of nano finishes. Okay. So this Teflon makes the product ideal for the cement plants or textile mills and any of the industries and all, where constant flow of dust and contaminants affect the conventional lubricants. That is the major idea where this Teflon came into the picture. Okay, so we will understand this through a small video. Okay, the Teflon. What is Teflon?
Teflon was in the spacesuits the Apollo crew wore for the moon landing, in pipes and valves used in the Manhattan Project, and maybe in your kitchen as the non-stick coating on frying pans and cookie sheets. So what is this slippery solid, and why doesn't anything stick to it? Teflon is a brand name for polytetrafluoroethylene, or PTFE. It was stumbled upon accidentally in 1938 by a 27-year-old American chemist named Roy Plunkett, while he was trying to develop a non-toxic refrigerant fluid for DuPont, a chemicals company. The strange white substance that formed inside his lab canister was chemically inert, meaning it wouldn't react with other substances. It also had an extremely low coefficient of friction, making other materials slide right off it. Teflon's properties make it perfect when you need something slippery, chemical resistant, or waterproof, which means it has a lot of applications. It can be found all over the place, as a coating on raincoats, industrial ball bearings, artificial joints, circuit boards, and even the Rocky Mountains themed roof of the Denver International Airport. The incredible properties of PTFE come from its molecular structure. It's a polymer, meaning it's made of long chains of repeating units of atoms strung together. A PTFE chain has a backbone of carbon atoms, each of which is attached to 2 fluorines. The fluorine atoms surround the carbon like armor, spiraling around the chain, and the bond between carbon and fluorine is incredibly tight. Like a couple that ignores everyone except each other, carbon and fluorine interact so strongly that the normal intermolecular forces that help substances stick to each other don't stand a chance. Even the famously adhesive feet of geckos usually can't get a grip. But wait, if PTFE doesn't stick to anything, how can it be so firmly attached to something like a pan? One method involves sandblasting the pan or etching it with chemicals to make it rough. Then a special primer is applied, which acts like glue. Its exact composition is a trade secret, guarded by each manufacturer. The pan is sprayed with liquid PTFE and heated to around 800 degrees Fahrenheit. The layers then solidify into a smooth, slick coating. When you later cook eggs in this PTFE-coated pan, the extra tight carbon-fluorine bonds just ignore the water and fat and protein molecules in the eggs. Without those interactions, the food just slides around without sticking. You might wonder if it's safe to cook in a PTFE-coated pan. The answer is yes, if you're careful. PTFE is stable at moderate temperatures, like you'd use to cook eggs or fish. But above 500 degrees Fahrenheit, it starts to degrade, and heating it further releases fumes that can make you feel sick. An empty pan can reach 500 degrees fast over.
Yeah. So, I hope from the video you understood how the Teflon and all are functioning. The fluorochemicals are the organic compounds which consisting of perfluorinated carbon chain. So this is a film former that reduces the surface energy of a substrate. In our case, it is a textile fabric or garment. So thereby providing one or more of the following properties. So these are the properties which will come by application of this Teflon. Oil repellency, soil repellency, water repellency. All will be repelled. Liquids will be repelled. Air will be passed. Air permeability, no problem. Okay, but so yesterday in the earlier video also we have discussed it, right? Waterproofing air vapor permeable fabrics. So fluorocarbons is the new one. Okay, whatever we discussed is these are also being used, but these comes under the nano finishes. This comes under the nano finishes. So the fluorocarbons which affect the surface tension, which forms a very thin film around the fiber, thus provide the fiber with a lower surface tension. Lower surface tension means it does not react and is lower than the most of the liquids. So finishing the fabric with hydroguard, so this forms the hydroguard, makes the fabric sufficiently water repellent so that it can imitate the lotus leaf. The lotus leaf effect can be created. So the hydroguard is a special fluoropolymer manufactured by process that do not produce any byproduct. No problem. So environmentally friendly and it will not react, and the fabric which is there, it will not increase the stiffness. The stiffness will be there, the drapability will be there, everything is good. Only thing is that it will not react with the water. It will not react with the water. Yeah, we will see a few videos also in further. But the soil release and stain release finishes are soil release and stain release. And stain release finishes, these are particularly important where leisure or sports wear. Okay, leisure wear means evening wear or for gown or evening parties and all, or for the sports activities, okay, which may lead to greater incidence of soiling and staining. Which may lead to greater incidence of soiling and staining. Wherever there is more chances of this soiling and staining will take place. For those applications, these finishes are very much important. One important factor which is in trend with towards the low temperature washing of garments, where the removal of persistent soil and stain removal becomes more problematic. Wherever the washing, the normal cold wash and all, the removal of soiling may be a problem. In those cases also, these finishes can be applied. Okay. So in principle, there are three groups which are developed: finishes that contains the carboxylic group, finishes that containing ethylene or hydroxyl groups, or the fluorocarbons. Okay. So the factors which affects the soil release finish. Okay. One is what type of soil it is, whether it is a red soil or black soil, or whether it is a dust or dirt, whether it is an oily soil or a particulate soil, or a hydrophobic or a hydrophilic or liquid, or what kind of soily soil. Okay, what kind of soil it is, that also will affect the soil release finish. What kind of fiber it is, whether it is the kind of fiber is a hydrophobic or hydrophilic, whether the surface is smooth or porous. Okay, how is the frictional surface of the fiber surface? Okay, like wool, if you see, scales will be formed, but silk, what happens? Very smooth in nature. So what happens if it is soiled for the wool? Removal is very easy. It is very difficult compared with the silk. Then the nature of textile means what is the construction of yarn, what is the construction of fabric, whether it is knit, woven or non-woven, whether the type of fiber is a staple fiber or filament fiber, whether it is a monofilament or multifilament. The nature of textile will also affect the soil release finish. And the effect of dyeing and printing, which has the measure. What kind of different binder films which are used, and what is the residual hydrophobic dyeing auxiliaries which are used, that also will affect the soil release finish. Okay. And the other finishes, like whether it is compatible with anti-static finish or easy care finish, and other finishings which are not harmed by the hydrophilic surface. Okay, whether this kind of surface is being modified, obviously the soil release finish is going to get modified. And whether it is compatible or non-compatible with the conventional repellent finishes. Okay, already a repellent finish is applied, on top of this the soil release finish is. So the three type of chemicals which we have discussed, right, which one is much suitable? So these are the various factors which are going to decide the kind of one which is used. But out of this, the Teflon is universally used. Okay, apart from this, what are the washing conditions, which detergents which are being used, whether the hydrodynamic flow in the washing machine, that also will affect the soil release finishes. So what properties which we are going to achieve by means of the soil release finish, if you ask? Add care to the garments. Okay, easy care will be there, and permits better wearability for improved soil release. So the dust and dirt will not affect. So what happens if there is a shirt which no need of washing? What will happen? It is so good, right? Yeah. See, there are few items which are available also, and which provides greater comfort in hot weather in compared with any of the resin finishes and all. That is much problematic. But with the soil release and all, what will happen? It will reflect the heat also. Okay, so it provides greater comfort with respect to the hot weather. Why? Because it is not coating the surface. It is allowing the vapor and air to pass. And it resists the depositing of soil when laundering, the re-laundering also. So we will see a video about the soil resistance and soil release finish.
Your morning cup of coffee gets bumped. Your glass of wine gets spilled. Your spaghetti is particularly saucy. Stains can come from anywhere. There's a couple things you can look for when dealing with apparel that's likely to get stained. Soil resistance means blocking a stain from happening in the first place. A soil-resistant treatment is especially effective against incidental liquid-based stains, like those that come from spilled oils, juices, or wine. These work by strengthening the surface tension of a fabric and preventing absorption, so that the stain-causing substances bead up and roll off the fabric surface before they cause a stain. Bartenders and servers in a restaurant often look for stain resistance in the clothes they wear to work. Soil release is meant for stains that have been ground into the fabric. This is a treatment designed to eliminate fabric stains in the wash. Soil release features are often best for stains that go beyond a simple incidental contact. Someone who works in an auto repair garage or a cook in a restaurant will definitely appreciate apparel with soil releasing features. Sanmar's Super Pro fabrics are both soil resistant and release stains in the wash, and can be found in many of our Port Authority Oxford and twill woven shirts and knit polos.
So, I hope you understood the earlier video. So, in this we will see a garment which is made like a lotus shirt. So, basically this concept is the same concept of finish as like the lotus leaf effect. With the same thing, if it is made into a shirt, how it is with the experiment that we are going to see in this video.
Everybody's wardrobe needs a good shirt, but do you really have a shirt suitable for you? Impermeable. Easy to wrinkle. Prone to stains and getting dirty. Restrictive and uncomfortable. So many issues with clothing that drive us crazy. Introducing Lotus Shirt. A tidy, anytime, anywhere. We owe our inspiration to the microstructure of the lotus plant. And we designed the fabric of our shirt to mimic the hydrophobic structure of the lotus leaf. Leaving you with a shirt that is always bright colored, fade resistant, and dry. Completely unaffected by the elements. So we named it Lotus Shirt. A shirt that is truly suitable for any business meeting, trip, or date. And with Fiber Secret's special weaving process, our shirt never wrinkles. No matter if you are walking, cycling, or relaxing, Lotus Shirt will never leave you feeling restricted or uncomfortable in any way. Even if you fold it into a small size or throw it in a travel bag. Our shirt is also designed to breathe. With more than 1 million micro holes, Lotus Shirt will not only keep you comfortable in hot environments, but it dries quickly too. After washing, simply hang to quick dry. No dryer is required. For those that suffer from heavy back shirt.
Yeah. So I hope you understood about this soil release finishes. So there are few other finishes are also there in this video, like peach skin finish. Peach skin finish. That means what happens, the fabric or the garment surface is so smooth. Okay. So as like the napping, we have discussed that one of the basic finish, right? Napping. Similar to napping, the peach skin effect also will be there. But it is basically done for the lyocell, that is a viscose alternative. So peach skin effects are produced in rope form using the air flows and air tumblers for a lyocell fabric. Okay, so as per the syllabus requirement and all, we are discussing some of these things. So the other alternatives are also open with finishing, where emery paper and all, by means of brushing the fabric and all, so raise its surface. Is it a functional finish? It is not a functional finish. It is only the comfort. It will not give any sort of soil release and all, but some sort of insulation can be given. Warmthness. Okay, that is about the peach finish. Similarly, aquatex finish is another finish which is basically for wovens or knits. So in this, what happens is water is mainly used. The chemical usage is very least. The water is mainly used. That is referred as a aquatex. By means of continuous washing also, what happens, the garments can be made into very small, smoother and all with the texture. So that is obtained through this aquatex finish. Okay. Then the feather touch and ultra soft touch. So the feather touch and ultra soft touch are nothing but the silicone softener washes which are being given. Okay, whether they are being treated with amino silicone or carboxy silicone or epoxy silicones, Okay. So depending upon that, the kind of finishes directly they are slightly going to change. So most commonly are used are like aminosilicones, which are extensively available in market and which are very widely used in the softening. Okay. So these silicone softeners, they impart excellent softness with bounciness. The fabric will become little rubber touch finish or feather touch finish. Okay, like bounciness will be there. So only with a concentration of 2.5 to 3% of weight in garment finishing can be given. But at some level, some sort of yellowing can be created, and a slight hydrophobicity. So this discoloration into yellowing and hydrophobicity. These are the slight disadvantages of this what we call aminosilicone acid finishes. Okay, the softener finishes, the feather touch and ultra soft finishes. So generally, apart from aminosilicones, epoxy silicones, which are very much comfortable or compatible with other finishing chemicals, which also impart softness without yellowing and improved fabric strength. It improved fabric strength. So that is the reason. But epoxy resins are little costlier than amino silicones. So that's why they also play a role in terms of wrinkle-free finishes by imparting improved tear strength. Okay, generally by means of giving this wrinkle-free finishes, a lot of strength is going to be gone up to 20%. But by increasing and giving these feather touch finishes with epoxy silicones, what happens is the surface will become more smoother, more peach-like thin, and also the strength reduction will not take place. Okay, means slight reduction will take place, but not up to 20%, maybe up to 5%. So in this, here we will see in this video how the silicone will be added during the finishing. Yes.
As you can see, this is softener and this is silicone. We will be adding this to our garment for a better and smooth effect. डाल दीजिए. This process will take another 20 to 25 minutes. And after this again, the garments will be washed in a plain water so that whatever leftover silicone or softener in the garments get washed away.
Yeah, I hope you saw this white compound which is added. That is nothing but the silicone softener. Okay. So the takeout of this video is we have discussed about various resin finishes, specifically the wrinkle-free or durable press, ETI, all these wrinkle-resistant finishes. Okay, the methods of applications, their advantages, disadvantages. We understood about the types of antimicrobial finishes and feather touch, rubbery touch, or stain-resistant Teflon finishes. So that is the end of this class. So we have another class of Unit 3 in another video about biopolishing that we will discuss in another video, biopolishing. So I hope we have learned something new today, and these are going to be very good and which makes an impact in your life in the coming years. So thank you very much for your patient listening. If you have any queries, you know how to contact me. So stay safe, stay blessed. Thank you.